7. And then Learning Unit 8 until Learning Unit 11 will be handled by Dr. Susanna, right? I mean, for the mass lecture. For the tutorial, will be handled by group lah, okay? Okay, basically for linear algebra, I think for the first two, I'm not sure whether you have learned eigenvalues and eigenvectors before this, but I think for the first learning unit 1 and learning unit 2, I think you have learned it during your PRAU or your STPM, or maybe your matriculations, yeah? So, okay, the first chapter is linear equations and matrices. Yeah, we will learn how to do operations on matrices and what is linear equations and so on. Yeah. So the first question. So given a linear system, so you are given this linear system. This is what we call, if you have more than one linear equations, we call it a system. Yeah, we call it a linear system. You can see here, we have 1, 2, right? So we call this a linear system. Okay, determine a particular value of t so that the system is consistent. Okay, I think you know this already. The system is consistent if you can solve the system, if you have solutions for the system. So for a linear system, for two linear equations, it is consistent kalau it's a linear equations, right? So it's a straight line. Yeah, it's a straight line. So it has a solution if it intercept with each other or the same line. So intercept ada dua line. Okay. Okay. So this one, the first one here, this is no solutions because there is no intersection between two linear equations. Yeah. And this one have one solution. The others are intersect at one point. So it has one intersections. Yeah. So it has one solutions. And the third one, kalau dia satu line yang sama, okay, means that it has many solutions. So intercept at many points. It has many solutions. So it is consistent if it is 2 and 3. It is consistent, it is number 2 and 3. Kalau dia ada solutions, means that it can either be one solutions or many solutions. Okay, then it is consistent. Okay, for question A, determine a particular value of t so that the system is consistent. So kita nak tengok dia consistent. Alright, so the easiest way for you to say it is consistent is to make the two linear equations sama, the same equations, because you know it is consistent kalau dia intersect with each other, right? So in this case, it is consistent if t is equal to 10. Why? Because if t is equal to 10 over 2, then equal to 5, right? So you have the second equation will be 2x minus 5, which is the same with the first equation. So if you draw the line, it will be intercept with each other. So you're going to have many solutions. So this is the easiest way for you to answer these questions. All right. So B, for B, a system is inconsistent. Ini kita cakap tadi kan. It is inconsistent when the lines do not intersect with each other. So means that these situations. Yeah, you see here, number 1 here. Here, okay, does not intersect with each other. So means that in this case, you can say that it is inconsistent if one of the value can be t equal to 3. Okay, and how many question C, how many different values of t can be selected in part B? Your answer will be as long as t is not equal to 10. As long as t not equal to 10, then we can say it is inconsistent. Tak ada solution. Okay. So in part B, you can say t can be anything lah. One of it, you can say t can equal to 3 or you can say t equals to 5. So as long as other than t equals to 10. Alright. Understand question 1? As for
Yeah.
yeah. Okay. Alright. As for question 2, it is similar with question 1. The understanding is similar. Alright. So you have given two linear equations. So A, you have to determine the value of t when it has many solutions. So in this case, if it has many solutions, so it's the same thing lah. Kalau many solutions, so you gonna dia punya mestilah intersect banyak tempat kan. Many solutions, yeah, it's the same thing. So what you do is you need to find what's the value for t. Okay, for t here, you see the gradient here have to be equal with the first equation. So negative 3 over 6 plus t is equal to negative 1 over 2. So your t is equal to 0. So that will be the answer for question A. Okay, t equals to 0 in order for you to have many solutions. In order for you to have the two linear equation intersect with each other at many places. Okay. And B, determine a particular value of t so that the system has a unique solution. Okay, one of the solution, this one you need to do it like try and error lah, alright? For one solution, one of the value will be t equals to 1, okay? And such that the second equations become y equals to negative 3 over 7x plus 30 over 7. Can you see this clearly? Let me zoom in lah a little bit. Okay, it become, so the value for question B, for question number 2, one value can be t equals to 1. It can be other value as well, as long as you can find the equations that intersect at one point. Okay, because you want it to be unique solution. Unique solutions mean one solution. Number 2 here, one solution at one point only. So you need to find equations that intersect with the first equation at one point only. So it can be other equations as well beside t equals to 1. So that's why I said it's more to try and error, try to find equations that intersect with the first equation at one point only. That is unique solution. Unique solutions in one solution. Okay. Okay, question number C din apa? How many different values of t can be selected in part B? Okay. For part B pula. For C, so the value for t is as long as t does not equal to 0. Because when t equal to 0 just now, you have many solutions. So you can say that as long as t is not equal to 0, so it will give you a unique solution. Provided you need to check whether is there any possibility that you gonna have a no solution situations. Yeah, in this case there is no solutions, so it's either many solutions or unique solution for this system. So A is for many solutions. So besides t equal to 0, other than t equals to 0, it will give you a unique solutions. Right? Okay. Basically, you need to understand how is the situations where you need to understand first, you need to understand consistent and inconsistent. So what situation it is consistent and what situation it is inconsistent. So always remember, consistent if the system has solution. Doesn't matter it is many solutions or unique solution. As long as it has solution, we said it is consistent. Okay? Inconsistent is when the system does not have solution. Kalau tak ada solution, you cannot solve the system, that you cannot find any intersections, then we say the system is inconsistent. Okay, you should know that for linear system, there are three types of solution. No solution, unique solution, and many solution. So you're gonna use this in chapter 2 as well, where when you learn to solve a linear system. So you're gonna see no solution, unique solution, and many solutions. And this unique solution and many solution is consistent, and this one, no solution, is inconsistent. Basically, you need to understand that. Right? So number 3, I don't think I need to discuss number 3. I think you guys okay kan? Number 3 is very straightforward. It's just an operation. So yang ini kalau you nak solve is like a simultaneous equations lah. Alright. So A plus 2B is equal to 4. 2A minus B is equal to negative 2. 2C plus D equals to 4. C minus 2D is equal to negative 3. So you have 4 equations. So you just solve it using simultaneously lah. Alright. Very, very straightforward. So you're going to have answer A equals to 0, B equals to 2, C equals to 1, and D equals to 2. Okay? No need to discuss, right? Boleh kan?
Yeah, boleh.
Right. And then this one as well, I think for the operation part, I don't have to discuss. You know how to do multiplications and all. Alright? Boleh Tak perlu So I just give you the solution for this one. For the operations part, for the multiplications. So this is the solution. Remember multiplications cannot be done kalau dia punya row and column is not the same for two means that if it's 2 by 3, the matrix is 2 by 3, can only multiply 3 times apa-apalah, right? This one and this one have to be the same in order for the multiplications untuk dapat buat lah, right? So always remember that. Okay, so this is, did you get the solution? So this is the solution for question number 4. Alright. Transpose, I think you know how to do transpose. Just, tukar column. Column become row, row become column. So that will be transpose. Can we move to the next question?
Yes, can.
Okay, for the next question, okay, compute the following entries of A, B. The entry of 1, 2. Okay, A, B. So matrix A is 3 times 2. Yeah, this is matrix A. Matrix B is 2 times 3. This is matrix B. Alright, so can multiplication be done for these two matrices? Boleh kan? Because of number of column is the same with the number of row, so it can be multiplied. So entry, so the size of the multiplications, how you know the size of multiplication is when A times B, the size, the result will be 3 times 3. Okay, that is how you decide on the size of the multiplications. So you're gonna have a 3 by 3 matrix when you multiply A and B. So you have the entry of A11, A12, A13, A21, A22, and A23, A31, A32, A33. So the 11, 12, 13, that is the position of the entry. Yeah, the position. So you want to compute the entries of 1, 2. So 1, 2 here, right? 1, 2 kat sini. So it will be the first row times with the second column. So for the entry 1, 2, you have to do this. You have to multiply and the product of the first row and the second column. So you kira, this is how you do it. I'll show you one. 2 times with -1 plus 3 times with 2. So you have -2 plus 6. So you have 4. Okay, that is for entry 1, 2. Okay, and entry 2, 3 is here. So it will be 2, 3. Okay, the second row times with the third column. So the second row times with the third column. Similarly, buat macam tadi, then you get 13. And entry 3, 1 sama. You just need to know which column and which row you need to multiply. And then you get 3. And D, you get 12. For entry 3, 3, you get 12. Okay, with question number 5, any question? Okay or not?
So far, no question.
Okay, number 6, very straightforward. Write the linear system whose augmented matrix is this one. So this is augmented matrix. So basically you need to know how to write augmented matrix daripada linear system and vice versa. So in this case, this is the augmented matrix. So you need to write the linear system. So basically this is the first, understand the augmented matrix. First row is the first equation, second row is the second equation, third row is the third equation, fourth row is the fourth equations. The column is the variable. So the first column is x1, x2, x3, x4. And then the last column is the answer, which is matrix B. Matrix B ni answer lah, answer of the equation. So 5, 3, 4, 6. So as long as you know this, you know that the row is the equations, the column is the variables, and the last column is the answers for the equations, and you can just write it back into a linear system. So kalau dah faham ni, then you know that you know that every time you want to solve a linear system, you need to change the system into augmented matrix, right? In order for you to do the row reduction. So you need to know this lah, vice versa lah, how to change from augmented matrix to linear system and linear system to augmented matrix, right? Okay, number 7, I don't think I need to discuss show one by one. So I just show you the solutions. This is multiplication. So A to the power of 3 is similar to A times A times A. So I need to do it lah. Kena buat lah A times A. Lepas tu baru darab lagi dengan A. B square is B times B. And AB is also, you kena buat AB first, A times B first. And then multiply 3 times lah. Okay. So this is the answer. You copy the answer. Okay, for B pula. For question 8, the last question in tutorial 1. So if inverse A inverse is 2, 1, 3, 4 and B inverse is 2, 5, 3, -2, find AB inverse. So from the properties of inverse, AB inverse is equal to B inverse times with A inverse. So as long as you know these properties, so what you need to do is you just multiply B inverse times with A inverse. B inverse times with A inverse. So you get 19, 22, 0, and negative 5. Okay? Tutorial 1 semua okay?
Okay, madam.
Alright, so we proceed with to tutorial 2. Okay, in tutorial 2, this is focused on chapter 2, which is in this chapter, in this learning unit, you learn how to solve a linear system. Okay, there are few methods to solve a linear system. So previously in chapter 1, you is familiarized with a linear system, right? A linear system is a combination of linear equations, kan? Okay. Now, in chapter 2, you focus on how to solve the linear system. Chapter 1 tadi kita cakap pasal inconsistent, consistent, and types of solutions, right? So now we learn how to solve the linear systems. And kat sini you will see how does the no solutions looks like, how does many solutions looks like, and how does unique solutions looks like when you solve a linear system. All right? Okay, now, first part in chapter 2 is you need to identify the type of matrices. There are two types of matrices, which is row echelon form and reduced row echelon form. Okay? Now, for question 1, find the reduced row echelon form of the given matrices. Show all the row operations you perform using a notation for elementary row operations. Okay, kalau reduced row operation, reduced row echelon form, RREF, RREF, when you have a matrix, RREF, the leading number in row have to be 1. Okay, and other numbers, other values in the same column with the leading one have to be 0. Okay, 3 lah senang. Okay, have to be zeros. You need to identify the leading one, and then other values with the same column with leading one have to be all zeros. Okay. Okay, contoh dekat sini, the second leading one is in the second row. For example, dia tak semestinya macam ni. For example, the second leading one is at the second row. So means that for RREF, you have to zero out everything else in the same column with the leading one. Okay. Example dekat sini, okay. Let's say here we have numbers 5. Here we have zeros. So do we have to zero out 5? No, because it is not in the same column of leading one. And for example, dekat sini pula ada 1. This is the third leading one. So means that, okay, we have to zero out everything else in the same column with the leading one. Okay? Understand? That is RREF. For RREF, let's say you have a leading one. RREF, you have to be, bawah dia mesti 0 lah, right? Leading 0 ones, or mesti 0, like this. And let's say here you have leading 1, and here you can have values. Sebab this is only RREF. You don't have to zero out 2. Okay? You don't have to make any numbers in the same column with the leading one become 0 because this is only REF. Kalau reduce REF, yes, everything with the same column with the leading one have to be 0 out. That is our REF. Kalau REF tak perlu. Contoh ini 3, ini 1, ini 1. See? This is REF. You don't have to zero out the same values of any numbers of the same column with the leading one. That is REF. Okay. Now, question 1, you want it to be reduced row echelon form. So you need to reduce it until you reach an echelon reduced row RREF. Okay. Now you look at the first one. Can you see this? Okay. Now you need to practice for this reduction. You need to practice on how to do a reductions lah. You cannot just depend on one questions and do satu kali and you think that you know how to do it already. So you have to try to practice to do a lot of reduction and then you can get the idea of it lah. You akan dapat itulah. You know, mathematics is all about practice. Okay, now you want to reduce. So this is your leading one, right? Good job. Oops, sorry. Cool. Okay, this is your leading one, right? So you have to zero out this and this. So you need a 0. So you have to zero out -2. So what I always do is, this is one of the way lah. Okay, means that you need to change row 3, right? So you need to zero out here. So that's why row 3, 2R1 plus row 3 will become the new row 3. So you do operations in row 3, you get 0, 5, 10. Sometimes when I don't want to get confused, I always do this. Because I want to change row 3, so I start with row 3. Check. Because I want to start with row 3, because I want to change row 3, I start with row 3. Because because you always bear in mind, the row that you want to change, you cannot multiply that row with any scalar. Faham? Kalau you nak tukar, for example, this one, you want to change row 3, right? You want to change row 3. So there must not be any scalar multiplication dekat depan row 3. Row 3 jangan kacau. Just let it be row 3 and then you kacau the row that you want to use to zero out. For example, row 3, because I want to change row 3, so I start with row 3 plus 2 row 1 and this will be my new row 3. Sometimes I write it this way because saya tak nak confuse. I don't want to put any scalar multiplications in front of row 3 because I tak nak. So I always start with row yang I nak tukar. Okay, I always start with row that I want to change. But it depends on you which one is you are more comfortable with. Because for me, I accept both lah. I accept both as long as the operations is the same. As please bear in mind, do not put any scalar multiplications in front of the row that you want to change. Dekat depan row 3 ni tak boleh letak negative 1 or because you want to zero out -2, you letak 1/2 macam tu. No scalar multiplication in front of row that you want to change. Okay? Ini tak boleh. So bear in mind. Okay. Macam tu lah. Alright. And then the next step is, see here is the second leading one, right? Number 1 here is the second leading one. So my next step will be zero out -2 and zero out 5. In this case, I can do it simultaneously for both row, provided I did not use the same row. I did not use the row yang I nak tukar. Okay, for example, for this one, I want to zero out -2. So I will have -2 is in row 1. So I want to zero out row 1 plus 2 row 2. So this will be my new row 1. And then I want to zero out 5, which is in row 3, minus 5 row 2. This will be my new row 3. You see the operation here is similar with this. It's just that the way I write it is different. Okay, because I want to remember that I cannot put any scalar multiplications in front of row that I want to change. Okay, you can do it simultaneously provided you not use, kalau you tak boleh macam ni row 1 plus 2 row 3 cannot do simultaneously because row 3 you akan tukar nanti, so you cannot use row 3 here. So you can do it simultaneously provided you only use row yang you tak tukar, which is row 2 for both. Alright, so once you have this, so is this RREF? Zero out, this is leading 1, this is leading 1, any values semua 0 kan? So this is RREF, so you can stop. Okay, for question B, similar, so you need to identify. So this is your leading 1, so here have to zero out. So we zero out simultaneously 3 rows. Guna row 1, see? Dia guna semua row 1, row 1, row 1, row 1. So zero out row 2, row 3, and row 4. So you're gonna have this. And you have to identify the next leading 1. So the next leading 1 will be here, 2. So first step is you have to make 2 become 1 first to make it become leading 1. So kalau nak buat jadi 1, you can times with scalar. If you want to make it become 1, you can times it with scalar. Alright, so you want to make 2 become 1, so you times it with 1 over 2. So for row 2, so you come 1. Okay, so this is to make a leading 1. So after you make a leading 1, you have to zero out other values in the same column. So which is 4 and 6, so you can do it simultaneously. Zero out 4 and 6 just now, and you're gonna have this as your last matrix. But you need to check. Is there any other leading 1? Tak ada kan? So this one just leave it macam tu lah because it's not in the same column with the leading 1. So this is RREF. Okay. Any question for question 1? Any questions on the concept, on the, concept of reductions, any things that you confused? You need to ask. Don't wait until nak midterm baru you tanya. You need to know how to do a reduction now. Okay. So if you have any problem, please don't hesitate to ask me, ask your friends, or ask me. Okay. Make sure you know how to do reduction because later on, kalau reduction you tak tahu buat and other things, determinants, eigenvalues, eigenvectors, you tak boleh buat because you don't. Everything needs row reductions. Kalau row reduction salah, then everything salah. Alright, question 2. Now you need to determine this A, B, C, whether it's REF or RREF. For question A, it is none. It is not REF. It is not RREF. Because why? Because there's no leading 1 here. So this is not RREF and this is not REF. For question B, this can be both because RREF can also be determined as REF. Yeah. So this is leading 1. So anything else in the same column is 0. So this is RREF. For C, this is leading 1 and this is leading 1, but the other value in the same leading 1 dia tak zero out, so this is REF. Okay. Okay, now number 3, find a matrix in column echelon form, that is column equivalent to A. Okay, tadi we talk about row reductions, row echelon form. So now we perform the reduction using column. That is why we call it column echelon form. So how you do it is similar with the row reduction. It's just that you need to be very careful because you buat guna column. Alright, it's different now because you buat guna column. So, can I just show you this? The concept is similar. The concept is similar because you want to zero out, because you want to do the column, so you have to be very careful lah. Kena buat by column lah, alright? So you have to zero, instead of zero out this, you have to zero out this. Okay, you have to zero out 2, -3, and 1. So this is the operations. You zero out the first row. Okay, and then you identify the leading one. So the leading one will be, the next leading one will be here. So you make it become 1. Okay, and then zero out anything below the leading one, because this is only column echelon form, bukan reduce column echelon form. So we need to zero out 5 here. Okay, it's a little bit different from the row echelon form lah. This is the operation, so you zero out it already. And the next one is you need to identify the third leading one, which is this one, the third leading one. So you have to make it become 1 by this operation. Okay, remember, if you want to make it become 1, you can times it with scalar. Okay. Okay, now this one will become the third leading one, and you have to reduce 3 over 2 becomes 0. So using these operations here, becomes 0. Okay, and then the last leading one will be -7. So you want to make it become 1, times it with -1 over 7, and then you have the last leading one here. And this is column echelon form. So you can stop lah. Alright. As for the reduced column echelon form, which is question B, they not continue to reduce until echelon form, because you already identify your leading one. So the first row here, tak perlu kan? Okay. Here is the second leading one, so means that you have to zero out -1. So this is the operations, zero out -1. And then the third leading one, you have to zero out -1 at 1 over 2 and 1 over 2 here. You have to zero out because it's the same column with the same row with the leading one. And you just zero out using these operations. Zero out and then identify, and this is the third, the fourth leading one. So you have to zero out 3 and -2. It will become like this. So this is reduced column echelon form. Okay. Similar method as row, it's just that in this case you use column lah. You have to be very careful lah. Right? Alright, question 4. Each of the given linear system is in row echelon form. Solve the system. So in this question, this is actually the end of after you reduce kan, you akan dapat, row echelon form and reduce row echelon form. This is row echelon form. This is actually when you change this into matrices, this is actually, kalau you letak kan, tulis dalam, this is actually 1 3 3 1 0 1 1 0 0 1 6 5 4. This is actually row echelon form, right? When you change it into matrices lah. Okay, this is actually the end product of your reductions. So in solving linear system, the first step is when you have a linear system, you change that into augmented matrix. Okay. Okay, when you have the first one is linear system, right? You have a system solve linear equations. Second step is change it into augmented matrix. Okay, augmented matrix. The third step is you need to reduce the augmented matrix. It's either REF or RREF. Okay, and the last step is after you reduce until REF or RREF, you do a back substitution. You do a back substitutions. Baru at the end, you akan ada result what is your X, what is your Y, and what your Z. This will be your solution at the end. So usually you're going to have a linear system and then change the linear system into augmented matrix and then start with the augmented matrix, reduce it into REF and RREF. And based on your lecture, you should know already REF is actually, we call it Gaussian elimination. This is the method where we reduce until REF. RREF is where we use Gauss-Jordan reduction. So kalau soalan tu cakap use the method of Gauss-Jordan reductions, then means that you need to reduce the augmented matrix until RREF. If the questions only ask you to use methods of Gaussian eliminations, means that you need to reduce it up until REF only. Okay, and usually kalau REF, then you need to go through back substitutions. Kalau RREF, you don't have to because you leading one will give you the answers directly. Nanti saya tunjuk And then the last part is you need to write your solution in terms of the variables. X equal to apa, Y equals to apa, Z equals to apa. So do not stop until jangan stop until reduction, stop. No. We want the solutions in terms of variables. X apa, Y apa, Z apa. That is the solution. That is the last solution that we want. Okay, now for back substitution, what do? Is you just masuk-masuk je lah. You know, we know that here is Z equals to 4, alright? So you just substitute Z equals to 4 into the second equation. So masukkan Z equals to 4, you get your Y. And then masukkan nilai the value for Z and Y into the first equations, then you get X. So this is the equations, this is the solutions that one. X equals to 4, Y equals to 1, X equals to negative 1. This is the type of solutions that we want. Okay. Now, B. For question B, okay, when you write it back into, ini kena tahu sikit lah. Write it back into augmented matrix. We want to see how does the matrix, the last matrix looks like after reduction. F1, negative 4, 5, and 1, 0 kan? And then 0, 0, 1, negative 2, 4. And then 0, 0, 0, 1 equals to 1. Okay, now. I tulis kat sini lah, lagi senang. So that it will be clear. Okay, now this is when after reduction you see something augmented matrix like this. So you know that previously I did mention that how many types of solutions you have? Can someone say balik, cakap balik? How many type of solutions do you have? You have 3 types of solutions.
3.
The first one is what? How many types?
Unique solution.
Okay, unique solution. Second one?
No solution. No solution.
No solution, correct. And the last one?
Infinitely many solution.
Yeah, many solution. Many solution. So when you look at the last matrix after you reduce, you can actually know already what type of solutions you're gonna have. So how do you know that? Kalau tengok macam ni kan, I always know that how many solutions, macam tengok, you look at the last matrix, how many solutions left? I have solution pula. How many equations left? I have 1. Remember, this is equation 1, equation 1, equation 2, equation 3. Okay, number of row is the number of equation. So I have 3 equations. Okay, how many variables do I have? This is variables. Yeah, I have variable 1, variable 2, variable 3, variable 4. So I have 4 variables. 4 variable. Yeah, I have 4 variable. So when number of variable is more than the number of equations, you're going to have a many solution. 4 variables and 3 equations. You have 4 variables, but you only have 3 equations. So you're going to have 1 free variables. I will explain to you what is free variable of this. Okay, you're going to have 1 free variable. Upper free variable. How do you write free variables? So when you look at this matrix now, when you look at this, okay, when you look at this, when you change this back into equations, you have W equal to 1, right? And then the second equation is Z minus 2W, right? Which is equal to 4. So you know what is the value for W. So you just substitute minus 2 to 1 equals to 4. So your Z is equal to 4 minus 2 equal to 4 plus 2. Sorry. 4 plus 2 equals to 6. Okay, so you have W equals to 1, Z equals to 6. And the first equation is X minus 4Y plus 5Z plus W equals to 0. Okay, so you substitute W and Z. So you have X minus 4Y plus 5 times 6 plus 1 equals to 0. So you have 4. So you have X minus 4Y. X minus 4Y, it will be 31 plus 31 equal to 0, right? You have this. So what is free variable? Free variable is when you have to let the variable become other variables. Maksud dia dekat sini, you cannot solve y, right? Because you only have this equation, so you cannot solve y. So what you do is, you let y become t. Any variable, you boleh letak r ke s ke. And you always write that where t is any real number. Okay, this is what we call free variable. This is what we call free variable. So you write your x in terms of t. So you're going to have x equal to 4t minus 31. So your answer will be x equal to 40 minus 31. Y equals to t. So you're going to write your solution. X is equal to 40 minus 31. Y is equal to t. Z is equal to, what is that just now? 6, and W is equal to 1. So this will be your solution. This will be how you write your solution. Like I said, kalau you tengok solution, the matrix, every time you see the number of variable is more than the number of equation, you know that this system is going to have a many solution. But how many free variables you have to let? You can substitute how many free variable is. This is how you identify. Number of variable minus number of equations. 4 minus 3, 1 free variable. So kalau you buat, you can notice that you only have to let 1 free variable. Free variable ada satu je t. Sometimes you have 2 free variables. So you can buat lah y equals to t, z equals to. So you already know how many free variables that you're gonna have to let. We don't want solutions yang x equal to 31 for y minus 31. No, that is not a solution. You tak boleh tulis solution in terms of y, in terms of variables y. You have to let it as free variables. That is how you write your solution. This is how you write a solution. This is a many solution. Okay, kalau unique solution is very straightforward. You are the, the first one, question A just now, this is a unique solutions lah. X equals to -1, Y equals to 1, and Z equals to 4. Very straightforward. But if many solution, you have to let it as free variable lah, kena substitute variable. Okay. Understand? So you should know how to write your solutions lah. Okay. Okay, now question 5, consider the linear system. Find all solutions if any exist by using Gaussian elimination method. Tengok Gaussian elimination, you only reduce until REF lah, right? So your first step is change into augmented matrix. This is the system, change into the augmented matrix. Start with the augmented matrix, reduce until you have REF. Because this is Gaussian elimination, so REF only is enough. So once you have REF, you change it back into equations and you do back substitution. Macam kita buat in question A just now. So we do back substitution. And this is very straightforward because why? Because you have 3 equations and you have 3 variables. So you're going to have a unique solution. You tak perlu ada free variables. Alright? So very straightforward. So you have X equals to 1, Y equals to 2, Z equals to -2. The most important part is you need to practice how to do a reduction, this part. I cannot teach you one by one because different system have different operations. So you have to do a lot of practice, okay? To do the operation, choose the operations and so on. Okay? Alright, now find all solution by using Gauss-Jordan reduction. Gauss-Jordan reduction, we know that if Gauss-Jordan reduction, reduce it until RREF. So yang ini tadi kita dapat from question A, right? REF. So means that now we want to use Gauss-Jordan. So you just proceed with the REF that we have and reduce it until REF. See? Until semua, any values in the same column with the leading one becomes 0. So reduce. So kalau RREF, if RREF, you don't have to do much. You don't have to do back substitution because you can directly get the answers from the last matrix. So you see here, Z equals to -2, Y equals to 2, and X equals to 1. So kalau RREF, you don't have to do back substitutions. Okay? If the number of variables and number of equations is the same lah. Okay? Alright. So number 6, solve the following linear system using Gauss-Jordan reduction with the given augmented matrix if it is consistent. Okay, now you are given this augmented matrix. Reduce using Gauss-Jordan reductions means that you need to reduce until RREF. So reduce until RREF. Ni RREF kan? Ni first leading, second leading. So everything else in the same column have to be 0. So this is REF. So now we want to write the solution. We have to know how many equations, how many variables in this last matrix here. We have 4 variables, right? We have 1, 2, 3, 4. 4 column kan? 4 variables. And we have 1, 2, 3. 3 equations. So how many free variables we're going to have? Tak ada. Mana ada 3 equation? The third row is all zeros. Means that you're going to have 4 variables, 2 equation. So you're going to have 2 free variables. So maksud dia awak kena substitute two free variables. So now what you do is you change this back into equations. Yeah? You change that back into equation. So you have this kan, x1 and x2. This is the equations that you get from the matrix here, the last matrix. So you know that you're gonna have to let 2 free variables. Because, why? Because you don't know what is x4 and x3. So what you do is, let x4 equals to t, let x3 equals to s, where t and s can be any real number. So what you do, you dah buat x4, x3. So you just substitute x3 equal to s into the second equation. And you have x2 equal to -1 plus 3s. and you substitute x3 and x4, s and t into x1, and you have x1 equal to 10 minus 9s minus t. So now you have your solution in terms of free variables. Tak boleh x1, you cannot just leave x1 equals to 10 minus 9x3 minus x4. You cannot just leave it that way. We have to substitute as free variable as t and s. Okay, remember that. So this is many solutions with two free variable. Okay, so basically you should know how to write your solution. Okay, similarly as question B, you are an augmented metric. What you need to do, reduce until I think this one is Gauss-Jordan semua tadi kan, Gauss-Jordan. So reduce until RREF. So what you do in here, you can see that you have 4 variable, 1, 2, 3 equations, so 1 free variable. So your free variable, you have to change back into equation first, and then you decide which one is your free variable. Always start from the last variable first. Always start from the last. If the last variable ada value, then proceed with the second last variable, and so on. So if the last variable x4, you cannot solve it, so you just let x4 equal to free variable, which is t, and then substitute. So you have x1 equals to 1 minus t, x2 equals to 2 plus t, x3 equals to negative 1 plus t, and x4 equals to t. Yeah, you have to write the equations, the solution based on the free variables. Okay, this is many solutions. As long as you have variables more than number of equations, you're gonna have a free variable. You're gonna have many solutions lah. Sebab number variable awak lagi banyak daripada equations. many solutions, then it is consistent lah, right? Okay. Question 7. In the following linear system, determine all values of A for which the resulting linear system has 1, no solution, 2, unique solution, 3, infinitely many solutions. So question A, you have this linear system. What you do is you change into augmented matrix first, and then you reduce because you want to see the last equation, the last matrix. So you reduce, so you have this matrix. Okay, now you need to know, as for the matrix, because you want to have a no solution, no solution. Okay, for no solution, if the number of variables and number of equation is the same, okay, in this case it is the same, 3 number of variables, 3 number of equations, so it's the same. So for the solution, for the no solution, it will happen if the last row is 0, 0, 0, okay, and then here got value. This will give you no solution. Why? Because it's impossible. So how are you going to solve this? Kalau jawapan ada, but we don't have any equations, so we cannot solve this. This is no solution. So if the last row give you 0, 0, 0, and then suddenly have numbers dekat jawapan, this will give you no solution. Okay, provided the number of equation and number of variable is the same lah. Okay, now many solution. The matrix will give you many solution if the last row is 0, 0, 0, 0. Okay, this will give you many solutions. And for the unique solution, the last row give you 0, 0, ada number sini, and ada number sini. This is unique solutions. For 3 by 3, for the number of equation and number of variables the same. Okay. Now for this case, it is 3 by 3. It is a number of variables and number of equation is the same. So you need to decide lah. Because A, you want to know the value of A if no solution, unique solution, and infinite many solution. So kalau no solutions, if no solutions, means that this a square minus 9 have to be equal to 0, but a minus 3 cannot be equal to 0 because you want it to make it become this, can the last row become this, because we want to make it become no solution. So the value for a can be a plus minus 3, and the value for a untuk sebelah sini, a cannot be equal to 3. So in this case, a have to be equal to negative 3 in order to make the system become no solution. A has to be equal to negative 3. Syarat dia dekat sini mesti 0, here have to be 0, here have to be not equal to 0. So that's why, okay, so that's why a square minus 9 equals to 0. So you have two choices, whether a is equal to plus 3 or negative 3. Okay, but on this side, we have to a minus 3 does not equal to 0. Because we want to make it become no solution. Kita nak buat dia jadi macam ni tadi. So a minus 3 not equal to 0. So a cannot be 3. So from here, we know that our a can only be negative 3 if we want to have the system have no solution. Okay? Alright. For number 2 is, I think, apa tadi? Unique. Alright, unique. So for unique solution, you have to be value, ada value dekat sini kan. So we have to write a square minus 9 cannot be 0. So a square cannot be plus minus 3. And a, on this side, a minus 3 cannot be 0 as well. So a cannot be 3. So our conclusion is, for this system to have a unique solution, a cannot be plus minus 3. Okay, untuk sistem ni ada unique solution, a cannot be equal to plus minus 3. Okay, how about for many solution? So for many solution, this a square minus 9 and a minus 3 have to be equal to 0. Sebab kita nak macam ni kan, row yang all zeros like this. Okay, so a square minus 9 equals to 0, a minus 3 equals to 0. So a square minus 9, so a is equal to plus minus 3 and a is equal to 3. So kita ambil satu lah, ambil yang sama lah, a equals to 3. So our condition will be a is equal to 3 in order for this system to have a many solution. Okay? Okay, understand so far for this type of questions?
Yeah, so far understand.
Yeah, and anyone else more okay? Alright. So for B, similarly, sama lah. Okay, you have the augmented matrix given to you. I think not given kan. You have to write it in terms of augmented matrix. And then the second step will be reduce lah. Tak ada lain lah. Kalau solving linear system, usually we reduce lah. Alright. So we reduce, we have this. So the similar thing, you have to know this syarat of no solutions, many solutions, and unique solutions. So for unique no solutions, so a square minus 3 have to be 0, but a minus 4 cannot be 0. So in this case, a is equal to plus minus set 3, but a cannot be 4. So our a for the condition for a, so that this system has no solution, is a equals to plus minus set 3. Because this side is, as long as it's not equals to 4, then it is okay. So we just choose a equals to plus minus set 3. Okay. And for number 2, for unique solutions, dia tak boleh equal to 0. This cannot be 0, and this cannot be 0, and this is also cannot be 0. So you just put a square minus 3 cannot be 0, so a cannot be set plus minus set 3, and a so as long as a not equal to 4, then it will be okay. So since it is not equal to plus minus set 3, so we just choose this lah. So the condition for A is that as long as it does not equal to plus minus set 3, then it will give you a unique solution. Okay, sebab tadi kalau dia equal to plus minus set 3, it give you no solution kan. For unique solution, as long as A does not equal to plus minus set 3. Okay, for many solution, so we want it to be all zeros. So A minus A square plus 3 equals to 0 and A minus 4 equals to 0. So you have choices of A equals to plus minus set 3 and A equals to 4. Is it possible to have A equals to plus minus set 3 and A equals to 4? Is it possible to be simultaneous? So no. So it is not possible for you to have all zeros row in this matrix. So means that it is impossible for this system. For any value of A, it is impossible for this system to have many solutions lah. That will be your answers. Okay, sebab tak possible kan. Kalau A set 3, takkan A equals to 4 pula lagi. Kan, it's impossible. So it's impossible for this system, for any value of A, it's impossible for this system to have many solutions. Okay, boleh? Alright, question 8. Find an equation relating A, B, C so that the linear system is consistent. So kalau consistent means that there are the solutions lah, right? Doesn't matter whether it's many or unique solutions. So we want to make this system, the value for A, B, C, you want to make the system to be consistent. So what you do is, since we want to look at the solution, so what we do is we change to augmented matrix. After we change to augmented matrix, tak ada lain, have to do reduction. That's why I said you have to practice reduction a lot until you know how to do it without any mistake, because you cannot do mistake in reductions. Once you do one mistake, then the thing you answer semua salah. So you cannot do any mistake, yeah? Have to do a lot of practice. So you reduce the augmented matrix with ABC just now, you're gonna have this. So in order, kalau you tengok ni, this is 3 by 3, 3 variables and 3 equations. If you look at the last matrix here, the syarat dekat sini is you want to make it consistent. So consistent means it's either many solution or unique solution. If you look at this, how can you make this become consistent? Is the only way you make this system become consistent is when A minus 2B minus C becomes 0. So the system will be consistent when A minus 2B minus C equal to 0. Dia akan ada many solution kan? Dia mesti 0, 0, 0, 0. Okay, it will have many solutions. Okay, so as long as A minus 2B minus C is equal to 0, then this system will become consistent. Alright. Question 9, inverse. This is one way for you to later on in determinants in chapter 3, you're going to learn how to find inverse using determinant. But this is how you find inverse using row reduction. Semua guna row reduction. That's why you need to know how to do row reduction. So the step of finding inverse using row reduction is on your left side is your matrix. This is matrix A and this is identity. So always start with this. Matrix A on your left side, identity on your right side. And what you need to do is you need to reduce these two matrix A and identity simultaneously, reduce until you have left side is your identity and your right side is your inverse. You have to reduce your left side to become identity. And automatically, once you have your left side become identity, automatically your inverse will be on your right. So your inverse will be, inilah. This will be your inverse. How do you make sure that you did not do any mistake? Is by doing a lot of practice in reduction. That's it. Okay. Dia senang je ni. The concept is very easy. Matrix A on the left side, identity on the right side. Reduce until matrix A become identity and your right side become your inverse. Okay, macam tu je. The concept is very easy, but the hardest part is the reduction part. Because sometimes we do mistakes kan. So satu mistake je, then inverse pun salah. Right? So do a lot of practice. Okay, now question 2 also kita buat reduction reduction for inverse A. So similar concept, A and I. Okay, and then reduce it so that your identity on your left side and your inverse on your right side. But in this case, if you notice, if in this case you have found that the last row become all zeros, so automatically you know that it is impossible for you to make your left side become identity sebab dah all zeros kan. So this means that there is no inverse exist for this matrix A lah. Maksudnya you can conclude that there is no inverse exist for this matrix A. Macam tu lah. If you cannot reduce it until identity. Okay. Alright. Okay, that's it for tutorial 2. Any questions? For tutorial 1 and tutorial 2, chapter 1 and chapter 2, any question? You guys okay? You understand the concept? So by now, you should already...
So far okay. So far okay.
By now, okay. By now, you should already know the concept of operation matrix. I think everyone know already. Plus, minus, multiplications of matrices. I think everyone, that one should be okay already. So basically, you should know the types of solutions. You have 3 types of solutions: no solutions, many solutions, and unique solutions. And what is consistent and what is inconsistent. You should know that. Okay? And you should know how to write augmented matrix as well. You should know how to write augmented matrix. And the most important part is you should know how to do reductions. Okay, you should know how to do reductions. If you still don't know, by now you still don't know how to do reduction, please do not hesitate to ask me or to ask your friends. Jangan simpan sorang-sorang. Nanti midterm nanti susah. Nak buat assignment nanti susah. Alright? So please make sure you know how to do reduction by now. And then, what else? And then make sure you know how to write your solution. You dah tahu macam nak reduce kan? And then the solution part, sometimes students tak tahu macam mana, don't know how to write the solutions. For unique solution, it's very straightforward. Yeah? X equal to 1, X equal to something, Y equal to something, Z equals to, values, numbers. But for many solution, you should know how to write a many solutions. I don't want you to write x1 equals to x2 plus x3. That is not the solution that we want. So we want the solution, if many solution, we want it to be in terms of free variables. So you need to know where to let the free variables. Dekat mana you nak let substitute the free variables. You should know that. I think so far that's it. So basically that is what you need to know by now before you go to the third chapter. I think third chapter is on this Friday, right?
Yeah.
Betul tak?
Yeah.
Yeah. So third chapter is on determinants. So you will learn how to calculate determinants lah, and what is the use of determinants lah. There are several use of determinants. So you will learn that on Friday. So we will have our next tutorial on Monday, the same time, 9 to 11. Okay, next week. So if you don't have any question, then we'll wrap up here. I will share again the QR code for those who came late. Okay, for those who have already taken the attendance, you can leave the session lah. Right? Goodbye.
Thank you, madam.
Thank you, madam.
Thank you, madam.